Implicit differentiation. This is the most important topic for the rest of the course. I might even spend 2 days on it. That's how important this is. We have enough time that I have an extra day built in. I only have 4 lessons for next week, and there's 5 days. No, 3 lessons for next week, and there's 4 days plus the review on Friday, right? So I have an extra day. I might be able to spend half of tomorrow doing this as well. Okay. We're going to say functions can be differentiated, and that's take the derivative. Implicitly. Example. So what we're going to say is, let's say you have an expression like x squared plus y squared equals 25. Okay. Why is this one more challenging or more awesome than anything we've seen before? There's 2 variables, right? And that's the thing. So we're going to basically take the derivative with respect to 2 variables at the same time. Now there are lots of functions that are like this. I guess not functions. Okay. Why is this one not a function? This is a circle, right? So basically the way you could do this, can you get rid of your phone, please, Steve? I need to be here today. So you're going to have basically that's either the positive square root would be one derivative, and the negative square root would be the second derivative. Okay, so that's a lot of work. So we're going to find a way to take the derivative of the whole thing at once. All right. So what we're going to do is take the derivative of both. And I'm going to say, remembering from the first day, y prime is the same as dy by dx. Then isolate dy by dx. Okay. So if you remember the very first day we did this, we said the other way to deal with the derivative is call it dy by dx. I don't know if you remember that. The very first day, that's what we talked about. And the reason I brought this up is because at the end of the course, we're going to be going back to that. And it's also very helpful. It's also very helpful to do when you get to university, we're doing equations like this with many variables in them. Okay. Okay. So here we go. I'll do a nice example to start off first.
Thank you.
And then I'll let you guys try one yourselves here. So example 1 says, if x squared plus y squared equals 25, find the equation of the tangent. At the point this is a classic question. Okay, and fundamentally important for the rest of the unit here. Okay, so what we're going to do is we're just going to say we're taking the derivative. We're just going to call it d by dx. So what we're going to do is, instead of saying like x prime and all that sort of stuff, we're just going to take the derivative of each part separately. Stay with me, Haley. You can do this, okay? Don't give up. Don't give up. Don't give up.
Where's the y?
Well, that's the thing is there's no dy by dx yet because we haven't taken it with respect to y, right? So we're taking this way. Just wait. Stay with me. Stay with me. Yes.
So you have to take it 2 times.
Yeah. 3 times, in fact. So we're taking the derivative of 3 things. It's just a different way to think what derivatives all it is. So all we're doing is we're going to take the derivative of x squared, we're going to take the derivative of y squared, and we're going to take the derivative of 25. All right? Go ahead. Okay. So what's the derivative of x squared going to be? 2x. Sorry, you asked away there?
Where's the y go in B?
Well, I'm going to show you where it comes right now, okay? I'm going to show you how it comes. So basically the way... Well, let's do how we do this. So what this is going to turn into then... Okay. So all that we're going to say then is whenever you take the derivative of y, whenever you take the derivative, do you want me to do it like chain rule? I'll do it with chain rule. How's that? Okay. Okay, so here we go. Let's use chain rule to take the derivative of this. This is just an aside. What's the derivative of something squared? 2 of the something. Times the derivative of what's inside the brackets, which just happens to be dy, that's what I call it. Okay? So then the dy comes in with here and change the dy over dx. Yeah? Oh, that's this part here, it's just 2x. Well, because this is what happens here, okay? When you're dealing with d by dx, x squared, it's going to be d by dx 2x times dx. So those two things just cancel, right? Like you're taking the derivative of, you know what I mean? The dx and the dx cancel out, so it's just 2x. That's the difference. Okay? Well, it does. Yeah.
So why did you multiply it by the
Just because that's just the derivative of x is just called dx. That's what we're saying. Just like here, the derivative of y is just called dy. Okay, but stay with me, stay with me, stay with me. Just stay with me for right now. I'm trying to explain. That's right, Michael? Yeah, the d just means derivative. That's all it is. Well, it's
Are you referring for
this just means take the derivative. That's all that means, right? So when you take the derivative of x squared, that's where it disappears, I guess. It's like 1 over dx, right? Because you're taking the derivative. No, d's not a derivative. Just like take the derivative. That's all that means. Okay. Sorry? Sort of think of it like that, yeah. Okay, so just the same thing that happened here then. When I take d by, just wait, stay with me here, just stay with me, please don't freak out, okay? When you do d by dx of y squared, okay, the d disappears because that means take the derivative, right? Okay, so you're left with 1 over dx times 2y dy. Are we all okay on 2y dy? Because all that means is the 2 comes down for y, the derivative of y is dy. So then you're left with 2y dy by dx. Okay, let's just go through a few of these and then we'll stress out. Do you want to ignore the second half of this question?
No, do it.
We'll do the whole thing. Go ahead. Please ask. I'm not here to stress you out.
I just don't understand what the second step, the third step.
You're okay on this first one? All the d by dx means the derivative of with respect to x. So you're taking the derivative of x squared, that changes to 2x. You okay with that? And the derivative of a number, 25, is just 0. You're okay with those two? They're just the middle part that's confusing?
Yeah.
Okay. So then and that's what I was trying to show up here. Okay. So you're okay with this idea of y squared changed to 2y dy? You're okay with that? dy just means, this just means the derivative of y. I think of it like we're doing a chain rule, right? It's just the derivative of y. Okay, so then what I was left with, I started with d by dx y squared. Okay, so that's going to be, the d just means take the derivative, so that changed to 1 over dx times 2y dy, which is 2y dy by dx. Okay, that's the logic behind it. Please be brave and ask. So I want you guys to understand this, right? That's the main thing. Go ahead.
Okay, so how did you get 1 over dx?
That's just the definition of when you take the derivative, the d disappears, right? Because d means take the derivative of whatever this happens to be, right? So until I take the derivative of y squared, so the d just disappears because That just means take the derivative. So once I've taken the derivative, I don't need to, so what's left is a 1 then. Yes, yes. Okay, so let's continue, hopefully. Sorry if I've confuzzled you there. Again, I know you don't believe this, but my goal is 100% understanding. Like, my goal isn't to, you know, when you leave the classroom, you say, whoa, I'm freaked out, I want to fail biology now because I'm freaked out by calculus. Okay, that isn't my goal, okay?
I'm only freaked out by most of them.
Until I their stuff.
Well, the question will happen to all the other stuff. Just remember, d by dx just means take the derivative of x. So the derivative of x squared is just 2x. Take the derivative number is just going to be 0, right? So that just disappears. And then the derivative of y is just dy. So now I have to isolate dy by dx. How do I do that? Press go.
Oh, dy by dx?
Yeah, how do you isolate that?
Oh, skip me. I got it.
Go ahead.
It's moved 2x over, that's divided by 2y.
Thank you. Now this is cool. I know you guys don't think math is cool, but I'm going to tell it to you. What does the first derivative mean again? Go all the way back to the beginning. Velocity is good. What else did it mean on a graph, though?
Critical points.
No.
Oh, slope.
Slope, thank you. Okay? So this is cool. What we have just figured out, that the slope of a circle is negative x over y. Okay, that's cool. That's what we just figured out. Notice the number disappeared. If I said x squared plus y squared equals 1, it's still the same slope, right? Nothing's going to change. Or x squared plus y squared equals 10,000. You know, nothing's going to change as far as that. Okay, go ahead, Michael. Oh, it's still there. Do you want to see it? I just moved it. It's right. I just put it over here. I didn't delete it. I just put it there. Okay, so in this case, we said the point is 3, 4, right? That's what we said. Therefore, in this case, m equals negative 3 over 4. Is everyone okay with that? Because my point was 3, 4, so I just subbed in x is 3, y is 4. Good. And I'm just going to finish with y equals mx plus b. Sorry, Michael, I'm going to move that over one more time. And then I'm going to stop here. Whoops, no, I'm not going to stop. I'm kidding. What I meant to say was I'm going to stop the video. So we're going to say y equals mx plus b, where m is negative 3/4, x is equal to 3, and y is equal to 4. So it's going to be 4 equals negative 3/4 times 3 plus b. 4 equals negative 9/4 plus b. 16 plus 9 is 25 over 4 equals b. Therefore, y equals negative 3/4 x plus 25 over 4 is the equation of the tangent. And that is cool. I think that's cool. Okay, I'm going to give you guys one to try for yourselves right now while I pause the video. Okay? Do you want one of that level or do you want one something worser? Slightly worser? I'm going to do a product rule. Now remember, the same rules apply. The only thing, hold on a second, the only thing you have to remember, what's the derivative of y called? What's the derivative of y called? Yeah, just dy, not d over dy, just dy. Right, so when you take the derivative of just plain y, it's just a dy. All right. I'm going to take the next question on the board, then I'm going to pause the video, and then we're going to get to it. So example 2 says.
I think he wants us to DI y.
Oh, that's not true.
Think yourself.
not equal 4. I'll make that equal 4. Instead of equals x, I'll make this equal 4. Okay, so what you're solving for is dy by dx. That's what you're solving for. Okay? Have confidence in yourself, you can do it. Do not just give up and fold your hands like this and wait for me to do it. Okay, you can do this. Alright? Remember I said this one would be a little bit challenging, so do one step at a time. That's a product rule. Okay? So remember how you do your product rule. Times 4.